Okay, so if f is continuous and differentiable on the open interval, so here we have a function, f. It has to be continuous and differentiable on the open interval from a to b. So if you look at this picture, it's clearly continuous. There's no break in action from a to b. And it's differentiable because, again, we have no break in action, we have no sharp points, we have no asymptotes in there. So it is continuous and differentiable on that open interval. And if that's the case, then there exists a number c somewhere in that interval. So somewhere between a and b, there will be a c value such that the derivative at c will equal the slope between the 2 points. So do me a favor and connect those 2 points. Very loosely speaking, Sam, is that a positive slope or a negative slope? Positive. Okay. And what we would do is kind of try to locate, what I'm going to do for this, try to locate the spot on the curve between A and B that's going to have the exact same slope. So I think I'm just going to put my lead over that line. So there's the slope we're looking for. If I kind of just roll my lead over, eventually we'll get to a tangent line of the curve that will pretty much show us where that point C is that has a slope that's exactly the same as the slope of that secant line. Does that make sense? Okay. So kind of estimate where that would be in that lower right corner of the curve. Uh-oh. I can't get my lead back in my pencil. So right down here in this lower corner is where approximately that C value seems to be in this picture. So the slope at C is the same as the slope connecting the endpoints of our interval. Okay? So that's the general concept. Now we're going to go down below and actually do something with it. So consider the function given here. And first and foremost, is this function continuous? Yes. Is it differentiable everywhere? Yes. Okay. So find the equation of the secant line joining negative 2, 4 to 2, 0. So in order to find or write the equation of the line, we need two features, at least. What are they? To write the equation of a line. Slope and point. Good. Okay, so we obviously have 2 points to choose from. I'm going to pick 2, 0 just because working with 0 usually makes everything easier. And then we just have to quickly calculate the slope here. We have our point slope, and we plug into the point slope formula. So y minus the y coordinate of 0 equals negative 1, x minus the x coordinate of 2. And if you want to distribute and go to y equals mx plus b, there it is. So by telling us those 2 points, they're giving us really the endpoints of our interval. So we just wrote the equation of that line. Now we're going to try to locate, as part B suggests, using the mean value theorem, to find the point C that's in that interval from negative 2 to 2. So somewhere between the x-coordinate of negative 2 and the x-coordinate of positive 2, there's a C value such that f prime of C will equal exactly the same slope that this one has. So with our function, what do we want our derivative to equal? What do we want the slope of our function to equal? Negative 1. Very good. We want it to be the same as the slope of that secant line joining endpoints. So we'll go ahead and find the derivative. So f prime of x is what, Lauren? Very good. Negative 2x minus 1. It's your basic power rule here, so nothing overly complicated. And we're going to set our derivative equal to the slope of the secant line. And this is when we solve this, this is going to tell us the x-coordinate at which that's happening. It's going to give us that c value that they've been talking about. So we add 1 to both sides, we get negative 2x equals 0, and x equals 0. But we want the entire point C. Obviously, this is only giving us the x-coordinate. So, Owen, what should we do with that x-coordinate to find the appropriate y-coordinate? To what? The original. Good. You want your point to be on the original function. So if we plug in and check out what f of 0 is, we get 6. So the point is 0, 6. Okay, and you should be able to kind of sketch a tangent line there and agree that that tangent line is parallel to your secant line, indicating that they have the same slope. And then we're just going to write the equation of the tangent line, so take a minute and do that on your own. Write the equation of the tangent line. Paul, are you done already? Okay. Oh, you could be. All right. Dylan, what'd you get? Anybody disagree with that? Anyone get anything different? Okay, good. So on, oops, what's that? Yeah, same thing. Yeah. So on that, I'm just going to graph this just to give you some I don't know, overall picture, I guess. Negative x squared minus x plus 6 is our function. And I'm going to actually graph the secant line that we came up with, negative x plus 2, and I'm going to graph the negative x plus 6. And the standard window should be fine here. And actually, I'm going to cut this down because they only wanted, really, we were on the open interval from negative 2 to 2. So if I go back to my window and look at this graph only from negative 2 to 2, I'm going to see that the overall slope, that's like your average rate of change in that interval, essentially, is obviously the same as the slope right at that given point. Our frequency, and you can see in that picture the tangent line that you guys wrote is exactly the same slope as the secant. Good? All make sense? Any questions at this point? Okay. So, let's flip to the back. And we're going to do more of the same, but we're just finding really that point C, or all the values for C, at which we would have the mean value theorem applied. So the first thing with any question involving the mean value theorem is making sure it can be applied on the interval. So it can only be applied, if you look back to the front, if it's continuous, if the function is continuous on the interval you're looking at, and differentiable on the interval that you're looking at. So in this first function, is this function continuous? Yes. And so if it's continuous, it's a cubic function. Actually, I would probably simplify this. It's just a cubic polynomial, so we know that those are continuous everywhere. Is it differentiable everywhere? Yes. So because they're continuous and differentiable everywhere, we don't really need to take a closer look at the interval. We would just assume it's also going to be continuous and differentiable on that interval. So now, if we're trying to find the value of C that has the same slope as the average rate of change along that interval, we first need to find the average rate of change of this function from -1 to 1. So we're going to need to find points on this function, -1 comma something and 1 comma something, to find the slope of the secant line connecting these 2 points. So what is f of -1 here? F of -1. What did you say? 2? I think it's 0. We have -1 minus 1, which brings us to -2, and -2 times -1 adds your 2 back, so you are at 0. And f of 1 is what? -2. Good. Okay, so the slope of our secant line, we're going to calculate now. -1 again. And so we want to find the exact point on this curve that has a slope of -1 also. Okay? So up until this point, I'll sketch for you what we have. I'm going to give you the graph x cubed minus x squared minus 2x. And our window is from -1 to 1. Okay, so from here to here is your average rate of change. I'm going to get rid of some of my y windows, so that's a little more dramatic for you. I'm going to go from like -3 to 3 should be okay. And then we see a little bit more clearly. Perfect. So here's our average rate of change along that interval. We're looking for the exact moment on the curve that we have an average rate of change, or an instantaneous rate of change also of -1. So we'll take our derivative, which is what, Emily? Perfect. And we want to know when our derivative, when our instantaneous slope is equal to -1. So what do I do to solve this? What would be my first step, Gina? Add the 1 over. Good. Because this is a quadratic. Is it factorable? Yes? What is it, Aaron? Perfect. And so at what 2 values is my curve going to have a slope of -1, Alec?
1 and 2.
Very good. X equals 1 and x equals -1/3. Now, which of those gets rejected? And why? I'll give you a second. No, I don't answer yet. I'll give everyone a second to think about that. Which of them gets rejected and why? Raise your hand if you think you know. Go ahead, Maggie. Correct, because 1 is an endpoint. So if you look at your mean value theorem, it says find all values for C in the open interval from A to B. And our interval from -1 to 1, that's obviously a closed interval, but if we want a C value in the open interval from -1 to 1 with parentheses, 1 is not included. Good? That make sense? So we would reject that, and that's our only x value at which that happens. And then obviously, does it say to find the full point, or are we just good to find the values for C? Yeah, it just says find the values for C, so we don't need to find the exact point. Now on our graph here, that would be at -1/3. So the slope here is the same as the average rate of change along that interval. Okie doke. 2 jumps to a trig function. Is this continuous? Is this sine, it's a version of a sine function, it's obviously not a straightforward sine function, but is there any place on this curve where it would be undefined? No, correct? Sine is never undefined, so we don't have to worry about that. It is continuous everywhere. Is it differentiable everywhere? Yes, we don't have any asymptotes, we don't have any sharp corner points on sine curves, so we're all good as far as the checklist to make sure that the mean value theorem can even be applied. Now we're going to do kind of the same, well, exactly the same thing. We first need to find the average rate of change from 0 to pi, and then we need to set our derivative equal to that. So take a minute and do this one on your own.
by 0, that's only 6. So, and kind of you're going, you only go to 5. So, you just want to check all those. Right by your ability. Is that your full ability? No. Okay. Check both of your points are wrong. You plug in 0 for sign of 0. Or 2 times 0, and then sign 2 times 0, 2 times 0 is 0, sign of 0, so 0 is 0. And then we check it out too. Check that too. Have you not? You don't have the y coordinate yet? What's the sign of pi? 0. So it's 2 times 0. 0. Okay. What's the sign of 2 pi? 0. So like kind of graph and then I read that one of our professional problems with Patrick. It's awesome. He said it was very easy. It's real time. You do all the commentary and everything. I'm very musical. You want to play teacher? Yeah, pick 3 numbers between 1 and 19.
I get 19.
How much do we know we're at? 17?
Yeah.
Oh, between 1 and 17. Ooh.
You pick yourself.
I think that. Oh. No. I don't even know what to do.
All right. Here is person A. Sam, pick one more number. Bryce L. You see anything wrong with this so far? Dan? For which point? Are you asking me, or are you being a confident teacher, and are you telling me? Okay. What should it be? Correct. So when you're first and foremost finding the endpoint, 0, 0, because the sign of 0 is 0. 2 times 0 is 0. Sign of 2 times 0 is the sign of 0 again, which is 0. 0 plus 0 is 0. So one endpoint should be 0, 0. The other should be pi 0. Okay, then this person also found the derivative. How do we feel about their derivative? Well, I don't really think we can play teacher with this because their derivative looks good to me, right? They've got the derivative of 2 sine x is 2 cosine x. The derivative of sine 2x required the chain rule, right? Derivative of sine is cosine, so we have cosine 2x times the derivative of what's inside. So that was fine. They set it equal to 0, and I'm curious how they did that. Whose is this? Dylan? How did you set it equal to 0? Because based on your points, it wouldn't have been 0, right? You need to set the slope of your curve equal to the slope of your secant line. You haven't calculated yet the slope of your secant line. Had you done that with that wrong coordinate 4, you wouldn't have gotten 0, so you would have had to set it equal to whatever slope you got. Does that make sense?
Yeah.
Okay. All right. Here's person number 2. Dan, how many points have you gotten to date? Do you know?
Today?
No, to date.
I think it's like 3 or 4. No.
That was your third.
Yeah, and I said 3 or 4.
Oh, okay.
So why do you give me that 34?
Well, because you upped it to 4. Well, I don't know if you were right. I couldn't remember if I wrote down your point or not. So you had 2 already. So you might have just snuck an extra one. I'm not sure.
I think I had 4.
You already had 2 prior to today? No.
Did I get 2 today?
No, you just got 1. Let me do this one this way. Raise your hand if you see a mistake. Because there is one. I just don't want to go through all the names if you guys don't see it. And it's worth a discussion anyway. But we might come back to this one because this is mostly pretty good. Whose is this one? Sam? All right, we're going to come back to this one. Let's just look at this one quickly, see if we see anything different on this one. This is all good too, right? We just haven't gone far enough. A lot of you are getting stuck right here. Oh.
Oh, I just read the teacher.
Well, you shouldn't have. You didn't know. Well, yeah, there is a mistake here. The derivative is not right, but you blew it. Now we can't play teacher with it. You should have just said, "Wait a minute, I found something," and then we could have played. The chain rule is necessary here. Cosine of 2x times the derivative of what's inside, so that just needed a 2. Good catch. Up here too. All right, so this is really where the majority of us are getting to an issue. Is this Elise?
Yeah.
Okay. There you go, Maggie. So I'm going to go back to Sam's, because Sam went the furthest with it, where we're looking for where 2 cosine of x plus 2 cosine 2x equals 0. So he subtracted over this term, he divided away his 2, and so he's looking for where the negative cosine of x equals the cosine of 2x, which is, there's no, way to really come up with this other than to start checking points. And we're only limited, obviously, to the points that, A, we know the values of, so your 0s, your pi's over 6s, your pi's over 4s, and so on. But also, we're limited to this open interval. This obviously is a closed interval, but we need to find values in the open interval from 0 to pi. So we really, if you check 0, 0 actually works. Is this you checking pi? Sam? Okay. I'm just going to get rid of that. If we check 0, cosine of 0 is what? 1. So we'd get negative 1 equals... Oh, no, it doesn't work. Does 0 work? 2 times 0 is 0. Cosine of 0 is positive 1. So that does not work. And even if 0 did work, it wouldn't be in the open interval anyway, was the point I was going to try to make there. But it doesn't work anyway. Then pi over 6. What's the cosine of pi over 6? Root 3 over 2 with a negative out in front. And the cosine of 2 pi over 6. 2 pi over 6 reduces to pi over 3. What's the cosine of pi over 3? 1/2. That doesn't work. We would jump to pi over 4. What's the cosine of pi over 4? Negative root 2 over 2. Well, it's root 2 over 2, but this has a negative out in front. Equals, what's the cosine of 2 pi over 4? And 2 pi over 4 obviously reduces to pi over 2. 0. So that doesn't work. So we're up to pi over 3. What's the cosine of pi over 3? 1/2. So that makes negative 1/2. What's the cosine of 2 pi over 3? Negative 1/2, because the reference angle is, yes, still pi over 3, still gives us the 1/2, but we're in the second quadrant now, where cosine should be negative. So guess what? We just found our first solution. Pi over 3 worked. Do we follow? Owen?
Yeah.
Okay. You made a noise that you're good though? Okay. So pi over 3 worked, and then we would check pi over 2. What's the cosine of pi over 2? 0. So what's the cosine of 2 pi over 2? No? Negative 1, correct. So that doesn't work. And we would go through, I'm not going to go through all of them because I already have, and I'm just going to save some time and say that that is the only one that works, I think. Aaron, did you find another one? Audit me. We're only going up to pi, remember. So I'm only cutting out a little early. If we think about our unit circle, I've checked pi over 6, pi over 4, pi over 3, pi over 2. And I would have to check 2 pi over 3, 3 pi over 4, and 5 pi over 6. But I don't believe any of those work. Okay? So you would go through those, though. I'm only cutting out early so we can get to that last example. You would go through those and check all of those. But it's a limited interval, so it's not the most fun thing in the world, but necessary to find the right point. So your answer is just at pi over 3. 5 pi over 6, you think, Mike?
Yeah.
Hold on, let's check it. The cosine of 5 pi over 6 is what? Negative root 3 over 2, because we're in the second quadrant, right? Negative root 3 over 2 with a negative out in front is going to make root 3 over 2. Does that equal, and then 5 pi over 6 times 2 is 10 pi over 6. 10 pi over 6 reduces to 5 pi over 3. And what is the cosine of 5 pi over 3? 1/2. It's actually positive 1/2, because that's a fourth quadrant angle. Yep. So that does not work. Okay? You know what? Let's check it here. Just because I'm pretty sure we got it. We'll check our function. We'll see. When does negative 2 cosine of x equal 2 cosine of 2x? And if I change my window from negative 2, no, I only need it from 0 to pi. I'll count by pi over 6. I don't know if negative 3 to 3 will be enough. If not, I'll change it. There's our first function. Here's our second. And it's only happening once. Okay? All right. Last example. Jess, can you pass that back to Sam, please? When an object is removed from a furnace and placed in an environment with a constant temperature of 90, its core temperature is 1500. So 5 hours later, the core temperature is 390. So we're going to create 2 points from that information. 0 hours after being taken out, the temperature is 1500. 5 hours later, the core temperature is 390. So just to be clear, our x-coordinate is hours and our y-coordinate is temperature. Okay? Why must there exist a time in this interval when the temperature is decreasing at a rate of 222 degrees per hour? Okay? So it's going to be a little bit of an explanation and a little bit of a justification. You need some work to back this up. The overall average rate of change needs to be calculated. And we're going to get 1110 over negative 5, which is negative 222. Probably not a surprise to most of you. So the average rate of change along that interval is negative 222 degrees. Because as the temperature is decreasing, is that continuous? When the temperature decreases, is there a break in action at some point? No, it's going to start off at whatever the temperature is, and from Algebra 2 and how things cool, it's usually an exponential drop initially, and then it kind of evens out towards the room temperature, which would be 90. Okay? So 5 hours later, it was still, if it started at 1500 and then it was still 390, 5 hours later, our average rate of change is negative 222. And so why at some exact moment must that be decreasing at a rate of 222? It's because of the mean value theorem. Okay? So something along the lines of, since the average rate of change along that open interval from 0 to 5 is negative 222 degrees per hour, there must exist a point in the 0 to 5 interval. What do we want to call our point? We'll call it C, just because that's what the mean value theorem calls it. Must exist a point C in the interval from 0 to 5 such that f prime of C equals negative 222. Okay? Any questions on that? Your homework is there at the bottom. 31 to 45 is just the odds. 51 and 57 are just kind of isolated problems. And then I want you to do 72 to 76 all, which I think might just be true-false. Okay? I'm also going to pass you back your test. So corrections for this will be due Tuesday. You're only allowed to do corrections on the original test, not on the bonus questions.